Welcome, everyone. We're so glad to have you join us for this special edition of the Good Food Institute's Business and Science of Alt Protein seminar series. Today, you'll be learning the key insights from a new GFI report anticipating production targets the plant-based meat industry must meet to satisfy anticipated global market demand by 2030. Now I'd like to introduce you to my colleagues who will be sharing the key insights from GFI's latest analysis. You'll first be hearing from Zach Weston, who's GFI's food service and supply chain manager. Zach works with manufacturers, suppliers, and upstream companies to scale innovation and infrastructure investment throughout the alternative protein supply chain. An active member of the effective altruism community, Zach holds a BA in business management and joined GFI after several years of experience in sales and working with startups. You'll also hear from Dr. Ryan Dowdy, GFI's Science and Technology Analysis Manager. Ryan spearheads technical analyses for GFI, oversees the work of our analysis team. Ryan has a doctorate in food science from the University of California, Davis, an emphasis in biotechnology. Prior to joining GFI, Ryan managed the food system for NASA's International Space Station. And Dr. Priera Pinescu, GFI's senior scientist with a plant-based specialty, will be joining us for the Q&A session. Pri's work focuses on accelerating the plant-based meat industry through analyzing the plant-based protein landscape and identifying emerging technological solutions and bottlenecks. Pri has a bachelor's degree in chemistry and math from the University of California, Santa Cruz, as well as master's and doctorate in organic chemistry from the University of California, Los Angeles. So let's get started. Zach, I will, turn the webinar over to you.
Thank you so much, Renee. I appreciate that kind introduction. And hello, everyone. Very excited to share with you the results from our analysis today. We'll be jumping through a few different slides here, looking at some of the key findings from the report and hopefully sharing and leading to some interesting questions and discussion during the Q&A portion. We can go ahead and jump to the agenda slide there, Renee. What we'll be discussing today are mirroring roughly the sections that are included in the full white paper, which is available for download on our site. And we'll be able to post the links to that, I'm sure at some point as well in the chat. We'll talk a little bit about some of the introduction to the analysis, what motivated us to do it, methodology we used. We'll be talking about the facility footprint for production capacity and the investment needs in industrial scale production. We'll talk a little bit about ingredient needs and industrial scales, and we'll finally close with some suggestions for next steps and, as mentioned, time for Q&A. It's incredibly important to point out this was a very large team effort here at the Good Food Institute. Our report authors have worked for months and months, well over a year, to get this analysis done and put together and ready for launch. So huge thanks to Maria, Hussein, Blake, and Ryan, as well as a number of contributors within GFI who provided data and insights, and then a lot of industry experts who were very gracious with their time and knowledge and made the report what it is today. So we're very grateful for everything that they contributed to bring this report to life. We can move on to the next slide. Thank you, Renee. For those of you who aren't familiar with us, I'll briefly introduce the Good Food Institute. We're a 501c3 nonprofit organization that's focused on creating a sustainable, secure, and just protein supply. We do that by focusing on meat, egg, and dairy alternative technologies. And we are programmatically focused in three key areas: science and technology, which Ryan is a part of. You'll be hearing a lot from, advancing sort of the foundational research and understanding of the technologies driving forward this category. And also funding open access scientific research through our grant program. Corporate engagement team, which I'm a part, which engages with different members of the industry at every step of the value chain to help make connections, share data and resources, and foster collaboration. And finally, the policy realm, where we advocate for global governments to fund R&D in this space and provide support to the industry, as well as guarantee a fair and level regulatory playing field for alternative proteins. And we do all of this work globally because we're trying to solve global challenges. We have about 100 or so team members across the world, primarily grouped in 6 different regions. We can move on to the next slide. Thank you, Renee. So why do we want to talk about all the things that are required to produce plant-based meat? Well, there are a number of estimates out there, commonly cited market projections from different market research firms. as well as consulting firms that forecast very high growth rates. And that's certainly exciting. And while we do see a really high uptake so far of consumer interest in plant-based meat across a variety of different demographics and geographies, we do know that the plant-based meat supply chain is going to have to scale if it's going to keep pace with this type of demand growth. You can see on the chart here, which is a combination of the yellow circles, which are referring to multiple alternative protein platforms, green circles referring to just plant-based, and blue circles referring to cultivated. But there's a lot of sort of viewpoints out there that suggest that there's a bright future ahead for alternative proteins, which is exciting. There's a lot of variance, of course, and there's a lot of directions it could go, but fundamentally, it's very promising. We can move on to the next slide, Renee. What's also helpful to understand or contextualize why we're doing this analysis is that this isn't a new thing necessarily. These types of large scale protein transitions have happened before. If we zoom way out and look at global eating trends, the biggest story in meat over the past few decades globally, as well as even in a lot of geographies like the US, has been the rise of chicken, which from a growth standpoint has far surpassed the growth that we've seen from other types of animal protein, such as seafood, beef, and pork. We at GFLI believe that we're at the beginning stages of a similar protein revolution and shift, only of course this time it's going to be plant-based meat and alternative proteins supplying that. We can move on to the next slide, Renee. However, getting there presents a lot of different challenges. This chart aggregates some of the different projections and predictions for alternative protein market share of the global meat market at various points in the future. The thing about market adoption curves and getting to these market share projections, however, is that while in some categories like software, the uptake and the growth can happen very rapidly, in the food and agriculture system where we're dealing with physical substances and products, transformation entails very significant ingredient and infrastructure supply chain implications that require a lot of lead time and upfront investment and capital to manifest. We've already seen demand outpacing supply in different parts of the plant-based meat ecosystem. In recent years, there have been stockouts on grocery store shelves and restaurant menus, as we're just simply unable to keep up with demand that we've seen. So if we assume that the estimates from some of the companies listed here and the ones listed in the previous slide are directionally accurate, that left us with a few really big, important questions. How many ingredients are we going to need to make this much plant-based meat? Will there be shortages of key raw materials that we need to make those ingredients? How much manufacturing capacity are we going to need to produce all of this? And how much is all of that going to cost? Those are the questions that really drove us to launch this analysis to understand what some of the supply chain needs are as we hit these demand growth targets. Move on to the next slide, Renee. So for this analysis, what we did is constructed a hypothetical production scenario where we assume 6% market share of the global meat market for plant-based meat. It requires approximately 25 million metric tons of production by the year 2030. In order to create this scenario, what we did is we took the market growth rate for plant-based meat between 2017 and 2019 from the US retail market. So 2 years of growth data, and that gave us a growth rate of 18%. That's focused on US retail plant-based meat sales. We then extrapolated to assume that that rate of growth, 18%, applies globally and will remain constant through the year 2030. That led us to this scenario where plant-based meat sales comprise approximately 6% of the global meat market in 2030. And from there, we converted the market share estimate into volumetric requirements. The Food and Agriculture Organization at the UN, or the FAO, projects that total global meat and seafood production or demand for human consumption is going to be approximately 400 million metric tons, and that's referring to retail weight. And at 6% market penetration, that would mean that the plant-based industry has to produce, as we have here, 25 million metric tons of plant-based meat in 2030 to meet market demand. This felt like an interesting benchmark, both because it seems like it's a very ambitious but potentially realistic growth rate. It also, of course, aligns nicely with some of the other estimates that we've shared from other third-party firms. I want to emphasize now, and we will continue to emphasize throughout this presentation, that this is not this is a hypothetical scenario and is not a forecast. This is not intended to be GFI's projection of what we think the market will be in 2030, but rather it's a scenario-driven analysis that's designed to allow us to extract directionally predictive insights that illustrate the innovations we need, as well as the investments that are required to hit some of the commonly cited production targets that are out there. So we don't view that this is exactly what the market's going to look like. It's just a hypothetical scenario to enable us to then model what the requisite supply chain needs would be. We can move on to the next slide. Thank you, Renee. To contextualize what we're talking about within the broader supply chain for plant-based meat and what's covered in the report, everything that you see listed here in the supply chain in green is covered in section 2 of the report, and we'll be talking about it on the webinar today. Everything that is in blue in this diagram is covered in the report in section 3, and we'll also be talking about that today. Everything in gray is not covered in the report, and so we will only be talking about it a little bit today. So as you can see, while we do talk about the crops that are used, we don't talk about the farmland requirements or harvesting and agricultural equipment that will be required for producing the crops that are used in plant-based meat. We do talk about some of the ingredients that are used and at a high level about some of that processing and what happens, but we don't have, as part of this analysis, a really good estimate or understanding of the infrastructure requirements or the investment needs for the raw material processing and fractionation capacity that will be required. And fractionation, they're referring to the facilities that are able to take harvested raw materials and turn those into isolates and concentrates. We do talk quite a bit about structuring the plant proteins, which we believe will predominantly be, or at least for the sake of this analysis, predominantly be low moisture and high moisture extrusion. And while alternatives to extrusion, such as 3D printing and fiber spinning, are outside the scope of this analysis, we do think those will play a significant role going forward. And then finally, on the downstream side of things, the end product level, where we're assembling structured plant proteins in with other ingredients and cooking them and coating them and packaging them for sale to consumers and for distribution, that is not covered in this analysis either. It often, or at least sometimes, will take place in the same facility as where the structuring and texturing of the plant protein is taking place, but it can and often does take place in separate facilities and even often by separate companies. So that just hopefully gives you a sense of the extent of this report. And so everything we're talking about is falling into either the green area or the blue area of this supply chain. We can move on to the next slide. As with any model, there are a number of assumptions and limitations that we had to make as part of doing this analysis. Among other variables, our model is sensitive to the forecasted demand growth rates, the volumetric capacity that exists today, the different types of products that we're demanding, the technologies that we're using to make those products, the utilization rate of different production facilities, whether it's a mix of high versus low moisture extrusion, et cetera. So we have a full list of all the different key assumptions and sort of gaps or potential sources of error in the analysis. It's available in the white paper itself in tables 1 and 6. But we wanted to share that at the outset, of course, because we know that we're missing things, and the data is often hard to come by in this category since it's often very proprietary and secretive and not something that we're aware of a lot of folks aggregating. But it's important that we put something out there so we can get feedback on it. And hopefully this becomes a living model that can be updated and improved over time as we obtain more and more feedback and data from folks such as yourselves. One thing I want to note at the beginning that I think is important to consider is that throughout the white paper and throughout today's presentation, we do not make any assumptions about future technological innovations, for example, in better ingredient processing or faster, more effective forms of extrusion. All of our assumptions that are used in the model assume that technology stays about the same in 2030 as it is today. So that means that any innovations that happen are pure upside as far as our model is concerned. So we're taking and utilizing today's technology to make our forecasts and not assuming that there are going to be key breakthroughs or innovations. We can move on to the next slide. Thank you, Renee. So let's jump into the findings of the report now with all of that preamble out of the way. And no surprise, of course, we expect that there are going to be some significant challenges and potential supply squeezes for certain key ingredients. We also think that there are going to be some different squeezes for production and manufacturing capacity. And we have identified as part of the report some suggested ideas for how we can mitigate some of these challenges. And Ryan will be talking a lot more about the ingredient side of things after I conclude this first section. I'll talk about manufacturing first, but at a high level, what our estimation is based on the hypothetical scenario that we've posited is that the industry will need to operate at least 800 or so manufacturing facilities, averaging about 30,000 or so metric tons per year of annual production at a global capital cost of around $27 billion US, within the decade in order to meet a 6% market share, 25 million metric ton production target. All of this analysis, we hope, underlines the very big importance of investment and innovation in these areas. And we hope that this helps to catalyze additional efforts in both of those areas. If we are unable to do this, if we're unable to meet some of these targets of building an effective ingredient and product manufacturing and structuring infrastructure, we think that is going to manifest in the marketplace as higher prices, higher costs of production, delays in manufacturing, and of course, limited availability to consumers. The tightness we already see in some of the ingredient markets, as well as the markets for things like contract manufacturing and producing products in existing infrastructure, is already creating a threat to the industry's sort of objectives to achieve price parity with conventional animal proteins. So every bit we demand further, every expansion of the category just adds more pressure to existing capacity for ingredients and for production. And that leads to sort of an inefficiency of scale, where the bigger we grow, sort of the higher prices are going to go, which is why it's incredibly important that we address these bottlenecks, and hence our motivation for the report. We can move on to the next slide and actually just jump directly from there into the following slide. So this first section is focused on the facility footprint that's going to be required for industrial scale production. The first thing I want to note here is the approaches that we considered as part of this analysis. Traditional processing is making products like seitan. It's been done for a long time, but it doesn't have the ability to produce very high fidelity analogs of animal meat. The second, what we call version 2.0, low moisture extrudants, has been used for the past several decades to produce what's often called textured vegetable protein, or TVP, but a dry shelf stable ingredient that can be molded, formed, mixed and formed to produce different types, especially of restructured or ground style products. This has been used in a variety of categories as a technology. So low moisture extrusion is used in the production of existing meat analogs today, as well as meat extenders that are added to animal proteins to make them go further in cereals and snacks, as well as in the feed industry, particularly for aquaculture feed. The third technology category we looked at for this analysis is high moisture extrusion, which is a relatively newer approach to extrusion that typically relies on twin screw extrusions or extruders. Not as widely utilized today, but it shows a lot of potential to create different formats and textures that are more analogous to certain cuts and formats of meat, and can more convincingly replicate that organoleptic experience. The final category is a grab bag of a variety of next generation techniques for producing texture and structure in proteins, plant proteins. This includes things like shear cell technology, 3D printing, fiber spinning technology, and other approaches. We chose, for the sake of this analysis, just based on where we are today and guidance of industry experts, and for simplicity, assume that the market in 2030 will be supplied by a combination of low moisture extrusion and high moisture extrusion. While we absolutely expect that the market will shift towards some of these novel and more sophisticated texturization approaches in the coming decades, we expect that there are still going to be a substantial portion of our plant-based meat demand that'll be met by these two technologies, low moisture, high moisture extrusion, simply because of their high throughput capacity, the fact that they're often already scaled or can be done with off-the-shelf equipment. They have a lot of cost advantages. And in the case of low moisture extrusion, can produce shelf-stable intermediate products and ingredients, and something that's broadly available, at least there's folks who are familiar with it around the world. This is an oversimplification, and that's part of where I'll remind you that we are trying to assume conservatively here based on today's existing technologies. And so any new innovations that can scale are pure upside for the category. As noted at the very bottom, our estimations of the structured plant protein, also going to be abbreviated throughout this presentation as SPP, structured plant protein. Our estimations of the manufacturing needs in 2030 in this scenario assume that low moisture extrusion accounts for about 80% of global volume, and high moisture extrusion accounts for approximately 20% of global volume. You can move on to the next slide. Next, we took a look at the extrusion lines, so the moving up one level, and put together several different archetypes for lines that would go into different facilities. The first one is a medium scale low moisture extrusion production line. The second one, line 2, is a high throughput low moisture extrusion line. The third one, line 3, is a medium throughput high moisture extrusion line, and line 4 is a high throughput high moisture extrusion line. In each case, we took a look at the existing capabilities or ceilings for each of these technologies when it comes to throughput and the costs, and then use that to build our overall model of how much throughput can be done in each individual facility. I will note that obviously equipment manufacturers and process service providers are incentivized to increase these numbers and improve these technologies. So again, all of our assumptions are based on today's current theoretical possibility or current limits, and do not reflect, innovation and breakthroughs that we think are very likely to occur as more and more attention and R&D is put into this sector. The other thing I'll note here too is that this doesn't mean that every single factory currently using one of these methods is producing at exactly this throughput. Throughput of various processes can vary depending on the products that you're producing, as well as the ingredients that you're utilizing. We can move on to the next slide. From there, we took a look at estimated global extrusion line and extrusion facility quantities in order to make sure that we're have a good estimate of the number of facilities that would be required. As you can see from this table, facility A is a mid-scale low moisture extrusion facility. Facility B is a large-scale low moisture extrusion facility with 4 low moisture extrusion lines. Facility C is a medium-sized high moisture extrusion facility with 2 extrusion lines, and the facility D is a large-scale high moisture extrusion facility with 10 extrusion lines. You can see the differences in annual output per facility, as well as the relative share of global structured plant protein production that we're assuming for the sake of this model. In order to translate the average output or throughput of these facilities into annual production model volumes, it is important to remember utilization rates. So we looked at each facility's capacity utilization through the lens of 24 hours a day operation, 7 days a week, 350 days per year, at about 85% of maximum potential throughput capacity. This represents several weeks of facility downtime for both voluntary and involuntary stoppages, which reflects industry best practices for things like maintenance and just unplanned shortages and the things that slow you down, like labor interruptions. According to folks we've talked to, the conventional meat processing facilities typically operate somewhere between 75 to 95% capacity utilization. So this assumption felt justified to us. We also did assume that quite a large number of these facilities would be fairly large and they'd be rather centralized of a market, that a clear majority, about 85% or so of structured plant protein would be made in this case, larger scale facilities that are on the order of or larger than facility B and facility D in this table. We expect that a lot of these facilities will be operated by large ingredient and commodity firms, as well as companies that have a large demand and maybe are running a fully vertically integrated operation that requires a large amount of structured plant protein. That share breakdown between large and small absolutely affects the outputs in the model, although not in a crazy way, but just something to be aware of that could obviously work out very differently from how we're predicting in this hypothetical scenario. It is, however, similar to roughly an 85%, 15% share breakdown that we see in the meat processing business, at least in the United States, on the conventional animal protein side, where the vast majority of animal meat is processed in very large scale facilities that are run by a small cohort of processing companies. So that brings us, with all of those caveats, to sort of the central question of the section: how many structured plant protein extrusion lines will we require if we're targeting a supply of 25 million metric tons by the year 2030? And from this table, we anticipate that roughly 2,000 extrusion lines would be required in approximately 810 extrusion facilities globally to meet that target. And we can go on to the next slide. Next, of course, we're interested in understanding what the amount of investment or capital expenditure would be required for each of these facilities as modeled. And what we're taking into account here are a few factors. Number one is land acquisition. So how much does it cost to, and where do we need to locate these facilities, and how much does that cost on average? Extrusion lines, so the equipment, which is not just the extruder itself, but also extruder control system, the vapor exhaust system, heat exchangers, both dry and wet material feeding, as well as some downstream equipment. These estimates for equipment were derived from proprietary quotes that were obtained from equipment manufacturers. So we factored that into each of these. And then facility development. So this is the actual physical construction costs for space for manufacturing, offices, and warehousing. I'll note that warehousing for facilities includes room for dry, sort of ambient temperature storage of raw materials. And for facilities that involve high moisture extrusion, we also modeled cold storage capacity as well. This is an important distinction between the costs, relative costs of low moisture and high moisture extrusion facilities, since high moisture extrusion outputs have to be chilled upon production. But it is worth noting that there may be some innovation breakthroughs that could lower this cost if different types of processing will enable longer shelf life and preservation for those products. You can see on this table hypothetical average capital expenditure required for each of these facilities, ranging from about $12.5 million US to up to a little over $90 million for the large scale high moisture extrusion facility. Again, as with everything else here, these are estimates that are not intended to precisely forecast what individual facilities are going to cost, but more provide directional and order of magnitude level setting for the industry. We'll next move on to operating expenditures, which is looking at how much it costs to operate each of these facilities on an annual basis. You can move on to the next slide, Renee. Thank you, perfect. And again, looking at these same 4 facility archetypes, estimating the different contributions from utilities like water, electricity, the cost of raw materials, labor, and miscellaneous considerations. You can see here a range of a little over $12 million annually, or almost $13 million annually for facility A, all the way up to almost $75 million US for facility D. And by multiplying the estimated number of facilities by each of their average operating costs for facility, our analysis found that we're projecting approximately $17 billion in operating costs within this hypothetical scenario in order to meet a 25 million metric ton structured plant protein production target. So next we can move on to a summary slide that talks about the total amount of cumulative global capital expenditure that's required in structured plant protein extrusion facilities by the year 2030. And as you can see, there's a pretty significant amount of growth that we need in the investment in this category. That is cumulative. It's important to point out. A few things to note here. There is a multi-year lag in making investments in capacity. So just because money has been spent in the year 2030 doesn't mean that that capacity is available immediately. Typically, it takes several years from when the investment dollars are allocated to when facilities are constructed and commissioned and fully operational, and you've worked out all the bugs and kinks in your manufacturing process. So this is something that is front-end loaded, and it's going to take significant upfront investment to reach some of the production targets that we've established in this scenario. And also, it's important to point out, as I mentioned at the beginning of the presentation, that this analysis was focused just on the facility costs for structuring plant proteins. It doesn't include all of the upstream needs for plant protein fractionation capacity and agricultural infrastructure that may be required. And it does not include all the downstream costs, such as the final product packaging and assembly steps that happen post-extruder in a manufacturing line, as well as other supply chain needs, such as equipment manufacturer investment and ingredient manufacturer investments that are required to scale those respective supply chains. So this is just a snapshot of one albeit very central and core part of plant-based meat manufacturing, but it is not a comprehensive look at all of the capital needs we have over the next few decades, which is something to bear in mind. We can move on to the next slide. One thing that does give us reason, I think, for optimism is that there is precedence for this level of infrastructure mobilization and investment. We can look no further than the clean energy space for that. Clean energy investment grew about 7x between the years 2004 and 2019, from about $40 billion US annually to almost $300 billion US annually, which represents a 14% compounded annual growth rate over that time, despite very high capital expenditures, or a similar dynamic to what we see in the alternative protein space. And in that time, roughly the same time period, 15% compounded annual growth rate of actual renewable infrastructure capacity additions. So we do know that when we are aware of the climate emergency that we are facing, that industries can mobilize and the financial sector can mobilize along with governments to fund a significant expansion of required infrastructure. And we think it's important that we help position alternative proteins, particularly plant-based meat, of course, as a part of this sustainable asset class. We can move on to the next slide. This is a look, I believe, through the end of the third quarter of 2021. We're about to release some updated investment figures that will include full year 2021. But as you can see, the investment to date in alternative proteins has mostly come from venture capital, equity-based financing, and it's certainly grown rapidly, a very significant compounded annual growth rate over the past few years, but that's really only a fraction of what's needed for future growth. Again, assuming as we are in this scenario that we're able to maintain very high growth rates through the year 2030. We can move on to the next slide. And that's, I think, a huge part of one of the key takeaways from this report is we really need to position alternative proteins as every bit of a climate technology solution as other categories which have received a lot of investment. In this chart on the left, you can see that the percentage or contribution of various industries to global greenhouse gas emissions. And you can see that global livestock or animal protein categories responsible for about 14.5%, transportation at 14%, and electricity, heat production, and other energy at 35%. The chart on the right shows the amount of invested capital in each of these sectors through the end of 2020. And as you can see, there's a significant imbalance in the amount of investment of alternative proteins relative to those other two sectors, in spite of the fact that it's equally or very similar level of contribution to our global greenhouse gas emissions. So we don't want to compete away capital from these other categories. They're obviously doing incredibly important work as well, but we really need to try to reach a level of investment that's commensurate with the amount of greenhouse gas emissions and the other sort of ecological footprints of the existing conventional protein category. We can move on to the next slide. So as part of this, of course, we really need to broaden our outreach and the amount of the types of investors, the amount of investment that's coming into this space, and establish the alt protein category as a bankable and investable green asset class that's every bit as impactful, profitable, and sizable as the renewable energy sector. We'll move on to the next slide, Renee. So what are some other solutions, some more technical solutions or business scale opportunities, that commercial opportunities we can think of in this space to solve some of these challenges we talked about? The first thing is anything we can do to expand capacity of existing facility. There are a lot of different types of manufacturing infrastructure out there that process various types of packaged foods. Some use extrusion, some don't. And so we really expect that some, not all, but some plant-based manufacturers or contract manufacturers may be able to purchase and stranded assets and repurpose, reutilize some existing facilities for at least part of this production process. We also really encourage companies to invest and governments to invest in production equipment innovation. So improvements to both the extruders that we're using today, as well as we alluded to alternatives to extrusion that can increase the throughput, lower the costs, improve the sensory quality. We obviously know from looking at this model that if we're able to bump up those throughput numbers, that has the potential to significantly reduce the facility footprint and infrastructure footprint that's required to meet our predicted or projected hypothetical 2030 demand scenario. So it's incredibly important we innovate there. We're also really excited to see sort of cross supply chain partnerships between key buyers and suppliers, especially within greening companies and equipment manufacturers, to figure out ways we can accelerate this process. It's going to take a lot of work, a lot of needed innovation and investment, and that requires, we think, working with established scaled suppliers and having established scaled suppliers and incumbents work with rapidly innovating startups to make sure that we can innovate quickly and then disseminate and commercialize those innovations as rapidly as possible. We also just frankly need to put money into this. There's a huge need for near-term investments and capacity expansion, and this takes time. If we have a need today, that means we're several years too late in meeting that need because it takes years to build factories and to line up the financing and get all of this done. So it's something that needs to start now, and that's why it's incredibly important that we mobilize private capital, particularly capital that is well suited to infrastructure and hard assets. That means primarily debt financing, more so than equity financing. So we really need to mobilize financiers like banks, as well as some players like private equity funds and a whole new class of institutional investors through either direct or intermediate means who are willing to invest in this category, in this asset class, rather than just relying on early stage venture capital, which is generally too small and doesn't have the right risk return and timeframe mandates to play in the infrastructure space. This also underscores a really significant opportunity for global policymakers. Public investment, particularly when blended with private sector financing, can significantly de-risk that private sector investment, crowd in a lot of additional private sector financing, and help incentivize the types of innovations we need to see on the R&D front, as well as the investments, the significant investments that we need in infrastructure to help make sure that the supply chain grows as fast as consumer demand does. There are a variety of reasons for why governments should do this, of course, and I think we're familiar with a lot of them, including the environmental benefits and the health and nutrition benefits. But there's also, of course, a really important story here of creating new jobs and creating a whole new sort of category of manufacturing livelihood opportunities. Move on to the next slide, Renee. You can find a lot of additional ideas for potential solutions to this bottleneck, as well as others on our website at gfi.org/solutions. This is a continually updated database of ideas for research that needs to occur, commercial white spaces that need to be filled by either startups or larger players that want to diversify their business lines into the alternative protein ecosystem. And we encourage you to check out that resource, as well as find ways to contribute to it if there's any other things we can add. With that, I believe I will turn things over. Next section focuses on the ingredient needs from this analysis. I'll turn things over to my colleague Ryan to take us through that.
Thank you, Zach. Next, let's discuss ingredient needs at industrial scale for 25 million metric tons of plant-based meat. Next slide. To investigate the plant-based meat ingredient landscape, we analyzed the ingredient list of the top 75 products with the highest US sales in 2020. The table on this slide shows the widespread use of a small number of ingredients across the 3 key plant-based meat categories that we analyzed. Percentages in the table represent the share of products from each category that contained that respective ingredient. These are the 8 most commonly ingredients, but it's not an exhaustive list of all the ingredients that are used by the industry. So unless a significant market disruption takes place, the plant-based meat industry is going to continue to rely heavily on this select group of ingredients and their respective corresponding raw commodities. Wheat and soy, for example, are produced at a massive scale, and their crop fractions are used in a variety of industries. The consistent, inexpensive, and high volume ingredient supply that these common commodity crops have make them really attractive to plant-based meat manufacturers. So the market is biased towards well-established commoditized ingredients because the supply chains for novel plant proteins and lipids are currently undeveloped, and they're more difficult and costly to build. Next slide. To calculate the expected global ingredient volumes that we would need to hit a production target of 25 million metric tons, we first identified the plant-based meat formulations that would dominate markets in the year 2030. So in analyzing the ingredient lists of these top 75 plant-based meat products, we found that 62% of them are wheat and soy-based, 16% are pea-based, 14% are soy-based, and the remaining share we attributed to an emerging protein products category. In our model, this is made up of a chickpea and pea-based formulation. Our analysis assumes that the plant-based meat landscape in 2030 roughly mirrors the ingredient composition of the top products in today's market. After that, we consulted with plant-based meat formulation experts, and we analyzed publicly available information on product labels to estimate the relative ingredient contents for each product by weight of each ingredient within that product. While each formulation here contains a variety of ingredients, we wanted to focus on key proteins and lipids, which are highlighted in bold here. These are prevalent across many products and formats, and they're utilized today at the greatest volumes. The high usage and the prevalence of these bolded ingredients suggests that they're most likely to experience bottlenecks as the industry grows. Next slide. We then combined that 25 million metric tons data point with our plant-based meat formulations, with ingredient production data, and with the United Nations Food and Agriculture Organization's commodity projections to extrapolate global ingredient needs for the industry in the year 2030. To illustrate this approach, consider one important ingredient: wheat gluten. We took the share of plant-based meat in 2030 containing wheat gluten, which is 62% of that total 25 million metric tons number, and 62% of 25 million metric tons is around 15 million metric tons. We multiplied this by the mass fraction of wheat gluten in that formulation, which is around 10%. So we expect the industry will require around 10% of 15 million metric tons, or 1.5 million metric tons of wheat gluten for plant-based meat in 2030. Using this method, the outputs of our model included projected demand for each ingredient, the share of projected global ingredient production, and the share of projected global raw commodity production that ingredient comes from in the year 2030. Next slide. Before we get to the results, it's important to note that different ingredients may require different types of production scale-up. In our report, for those ingredients where the percentage share of projected global ingredient production is high, expanding intermediate processing, like protein isolate and concentrate production capacity via increased investment, will be sufficient to address the bottleneck that's likely to occur. And this can be done without necessarily committing any new acreage to be cultivated. Next slide. However, some additional cultivation of the commodity may be required if particular cultivars are required for that specific ingredient. Next slide. For key ingredients where the share of projected global raw commodity production is high, increases in raw material production, along with increases in intermediate processing capacity, may be required. Even in this case, if higher yields can be obtained through intensification practices like breeding or improved agricultural practices or better protein extraction techniques from that raw commodity, then no new acreage necessarily needs to be farmed. Next slide. This table shows the outputs for the 8 key ingredients that were mentioned previously, along with their projections for the year 2030. This includes their projected demand in million metric tons, their share of projected global ingredient production, and their share of projected global raw commodity production. Next slide. Let's back up one slide here. First, I want to highlight soy protein concentrate. Without additional investment, the plant-based meat industry may require 3 times the projected global supply of soy protein concentrate. Because soy protein is a derivative of one of the most widely traded global commodities, supply chains are well developed from farm to fork. However, a large fraction, probably 2/3 of global soy protein concentrate, is an alcohol-washed, low concentration product, around 60 to 65% protein, that's less suitable for plant-based meat. Instead, it's often used as animal feed, particularly in aquaculture. This can make it difficult to repurpose soy protein concentrate manufacturing infrastructure for human consumption in plant-based meat. Still, soy protein concentrate is positioned to remain a dominant source of protein as the plant-based meat industry grows in the coming years. Next, I want to call out pea protein. This is showing 10 times the share of projected global ingredient production. Assuming current yields and without any further investment in processing capacity, this means the plant-based meat industry may require 10 times the projected global supply of enriched forms of pea protein and 34% of global pea production overall. Pea protein, which is commonly sold as an isolate, has seen significant growth in the last decade. It has a clean taste, good functionality, low environmental impact, it's non-GMO, and it has non-allergenic qualities. This has led to its widespread use in the plant-based meat industry, and ingredient suppliers are significantly increasing their production capacity to satisfy that market demand. Roquette, for example, recently announced that their yellow pea facility in Canada could process up to 125,000 metric tons of peas annually once this facility is at full capacity. But due to a relatively low protein content of 28%, the manufacture of pea protein leads to a large volume of byproducts, particularly pea starch. A lack of viable commercial uses for pea protein byproducts like starch has made its production highly susceptible to volatile commodity prices. So here, the growth of plant-based meat will put pressure on the global pea supply, but the biggest bottleneck that we see here is processing capacity. Additional investments into processing capacity to create pea protein isolates and concentrates would quickly unlock much greater volume in terms of this ingredient. The bottom line here is that without greater investment to improve the commercial viability of pea protein side streams, the price of the ingredient may become restrictive, and its potential use by the plant-based meat industry can't be fully realized. The third and final ingredient I want to point out here is coconut oil. Without intervention, the plant-based meat industry may require 16% of the global supply of coconut oil in the year 2030. Demand for coconut oil is expected to grow in the coming years. It has widespread use by the food and cosmetics industries. Thanks to its high saturated fat content, which lends itself to good functional properties in food and cosmetics, it's become an essential component of a large share of plant-based meat products. However, there's a challenge here. Over 70% of current coconut oil production takes place in Indonesia and the Philippines. So the commodity is heavily export dependent, which can lead to supply constraints and price volatility. If coconut oil retains its dominance in plant-based meat formulations and alternative means of production are not developed, additional investments in processing capacity and overall coconut cultivation would likely have to increase to keep pace with increased demand. So the plant-based meat industry's heavy reliance on coconut oil, coupled with its relatively volatile supply chain, suggests that the industry should seek to diversify into alternative fats that provide similar or superior sensory characteristics. Novel manufacturing methods for producing similar fats, such as using microbial strains or modifying more abundant plant fats, should also be explored. Next slide. Now, let's move on to key takeaways. One of the key takeaways from this report is the need to explore opportunities in emerging protein sources. There's a significant gap around consumer needs for cost, taste, and sustainability. Current crops have often been engineered specifically for yield and throughput for industries like feed, fuel, and industrial use. And this requires heavy processing to reconfigure them into forms suitable for human consumption. There are multiple benefits to be gained if we can optimize each step of the supply chain with that end application of plant-based meat in mind, instead of using it for other end purposes like aquaculture feed. The chart on this slide is an overview from GFI's Plant Protein Primer. This is our deep dive into the supply and demand characteristics of the various plant proteins that can be used for plant-based meat, egg, and dairy products. Next slide. Another key takeaway is that side stream utilization can improve the economic viability of the existing ingredients that are used by the plant-based meat industry. The conventional meat industry uses almost all parts of the animal, and we can do the same for alternative proteins, creating a new food industry that utilizes every part of the plant or biomass source. The larger protein fractions are well suited for plant-based meat, egg, and dairy products. Amino acids and small peptides are useful for cultivated meat production. And finally, the remaining sugar and starch fractions are useful as feedstock for microbial fermentation and as scaffolding materials for cultivated meat. In general, side stream use should be an explicit consideration as ingredient suppliers and plant-based meat manufacturers screen and breed new specialty crops specifically for plant-based meat. The economic viability of novel crop supply chains can be greatly enhanced by identifying value-added implications for starch and fiber-rich fractions, like as fermentation feedstocks. Similarly, the industry should also investigate potential opportunities to use the side streams of other industries, such as spent grain used for brewing, as cost-effective inputs for plant-based meat. Next slide. Next, Forging partnerships among ingredient suppliers and plant-based meat manufacturers is key to scaling up the production of plant-based meat. Proteins are often extracted to improve their properties for a specific set of applications. And often this process also removes some protein components. And the type of process used determines which components are retained and which are removed from that final protein product. The process can also intentionally or unintentionally alter the functional and nutritional properties of these proteins in a variety of ways. And that includes denaturation, hydrolysis, chemical modification, and cross-linking. Because of this, strategic relationships between ingredient suppliers and plant-based meat manufacturers are key for providing those suppliers with timely information on demand changes for their starting ingredients. Ensuring future income through guaranteed offtake agreements can de-risk new investments in processing infrastructure, empowering processors to build capacity in advance of the materialization of market demand for plant-based meat. These relationships can also harmonize the maturation of ingredient supply chains with the needs of manufacturers, allowing plant-based meat producers to provide feedback on the degree to which ingredients are meeting their functionality and consistency needs. For example, in recent years, Cargill announced an investment in the company Purus to increase the production and processing capacity of its proprietary pea protein. And this enabled Purus to fine-tune its protein specifically for the plant-based meat industry. Next slide. Finally, let's talk about fat. Fat is a key contributor to the sensory experience of eating meat and dairy. Investing in new technologies for fat for plant-based meat production will enable the supply chain to support a high level of market penetration. With fermentation technology, for example, companies can produce a wide array of fats that are critical to replicating the flavor and the mouthfeel of their animal counterparts. 2021 was a breakout year for companies focused on oils and fats. 4 of the 7 fermentation companies that are developing oils and fats for use in alternative proteins were founded just last year. And you can see a sampling of them here, including Cultivated Biosciences and Milton Marble. Other fat solutions include enzymatic transformation and oleogel formation. So in recognition of this urgent need for new fat solutions, GFI also launched a research funding opportunity last fall. This solicits research proposals for new fat sources and structuring methods to address this looming need. And we'll be able to announce 5 new grantees working in this area in the coming weeks. Next slide. So where do we go from here? This assessment is the first that we're aware of to provide a macro scale view of the plant-based meat industry's future footprint, including both volumetric ingredient needs and the extrusion production capacity that's required for the industry as a whole. We hope it provides direction to investors, to ingredient processors, to equipment providers, to policymakers, and to plant-based meat manufacturers. This tells the urgency of the industry, the opportunity that's there, the level of investment that's necessary to meet these ambitious production targets of 25 million metric tons in the year 2030. Here, entrepreneurs can also benefit from the report by estimating ingredient volumes and facility expenditures as they scale up from pilot to commercial scale production facilities. The industry shouldn't underestimate the challenges and opportunities in expanding the plant-based meat supply chain. We want this to be at a scale rivaling that of conventional meat. However, it's worth noting that the plant-based meat supply chain and production processes exhibit structural efficiency and flexibility advantages over their conventional meat counterparts. These advantages can significantly improve the industry's resilience and reduce supply chain vulnerabilities. And this leads to long-term competitive edges for producers of plant-based meat. These considerations, in addition to the profound benefits for the environment, for public health, and for global food security, make these investments in plant-based meat well worth it. Next slide. Ultimately, our analysis leads back to increased investment as a key driver for the alt protein industry as a whole. Over the past few years, we've seen strong consumer enthusiasm for plant-based products. Even with premium pricing and early days product quality, this demonstrates that there's demand for meat, egg, and dairy alternatives that are taste and price competitive with their animal protein counterparts. This demand is driving investment from global governments, investors, and existing companies into research and development and scaling the supply chain for higher product output. Research is creating innovations that are improving product quality, like better taste, improved functionality, and versatility. And the scaled supply chain increases the quantity of products produced, which lowers their price and expands availability for consumers. Improving product quality and making these products more accessible to consumers will continue to increase demand, completing the cycle and creating an ever-accelerating feedback loop. The Good Food Institute is working to help channel resources and efforts in the right direction. Investors, government, and existing industry players can fund needed technical research, and as breakthroughs are achieved, help disseminate those insights as rapidly as possible by commercializing and scaling promising new technologies. This enables sensory and price parity with animal alternatives. Investments also allow suppliers and producers to scale needed intermediate processing and manufacturing infrastructure. As economies of scale enable lower product prices, and R&D innovations drive product taste and functionality improvements, distribution and sales partners can benefit from increased consumer category recognition for the plant-based meat industry. Next slide. That concludes our presentation. Thank you so much for your time today. To learn more, you can download this report from our website. You can also check out the wealth of other resources at gfi.org. And that includes GFI's Alt Protein Opportunity newsletter at gfi.org/insider. At this point, I'll turn it back over to Renee, who will be moderating the question and answer session. And we'd love to take a few questions.
Thank you so much, Zach and Ryan, for that insightful presentation. That was fantastic. As a reminder to our attendees, you are welcome to submit your questions in the Q&A box, and we'll try to get through as many as we can in the next 15 minutes that we have together. Right, let me get over to my question document here. Lots of good questions to get through. One here is, will farmland projections and raw material processing be centered in future reports? And why is the raw material processing and fractionation equipment not covered in this report?
I can jump in real quick on that one. So there is a real challenge obtaining data on the plant protein fractionation side of things. So we're starting to do a little bit of work in that area, but it's really difficult to obtain that type of information. We are planning later this year to, Ryan and his team are working on a sort of broad manufacturing capacity analysis that should hopefully cover some of that. But also this was a fairly complex model, even without including all of that in it. So we wanted to at least start here and get that out there before we move into that area. But if anyone has any data or feedback or contributions and ways we could expand the analysis to include that, we would love to talk with you about it as an area of obviously an incredibly important bottleneck in the space today.
That's very helpful. Thanks, Zach. So the market size of plant-based meat should be varied depending on the geography. Do you also have market estimation region by region in 2030?
You bet. Thanks, Renee. I can take that one. Whoever asked that question definitely beat us to the punch on next steps for the model. We're so excited to take the model in that direction. Right now, we're focused on the global scope of plant-based meat. And because information can be really hard to come by, this first step was critical to understand what does plant-based meat look like in terms of total amount that would be needed in 2030. So next steps, we do want to look at specific geographies, and that's definitely a great opportunity to apply the model to specific geographies. And at that point, it can really, really become very useful to policymakers in specific geographic regions.
Excellent. Thank you, Ryan. Now we have a question that addresses our current state. And maybe Zach could take this one. But so the question is, compared to the rate of capital deployment, factory creation that you have modeled is needed by 2030, where are we currently? Are we meeting these requirements year on year, or do you think that it is likely that we won't hit creating a supply constraint?
I think it's pretty likely that we're going to run into supply constraints. We've heard a lot of anecdotal reports from manufacturers, the constraints on the contract manufacturing side, as well as a lot of just challenges and delays with spinning up new self-operated manufacturing capacity. So as we said before, it takes a long time. It takes a lot of investment, of course, to do that. And that's where, you know, existing incumbent players, corporates with large balance sheets and who are familiar with this process can short circuit it and accelerate it. But we really need to see the industry step up and forge the partnerships that lead to additional capacity. It is a little bit hard to pin down exactly how much capacity exists today, simply because a lot of that data, as we've said multiple times, tends to be fairly proprietary to individual companies, and there isn't, as far as we're aware, any great aggregation of the relative capacity and throughput of various facilities. There's also a lot of variability, just given how new of a category this is, and degree of variability in ingredients and the equipment. So some companies, I'm sure, are producing really high, much higher throughputs than anyone else, just because they're paying attention to this category for the first time. It is easier to obtain sales data, so we are able to sort of gut check our assumptions using that. But of course, we do have to do a conversion, of course, into actual production volumetric amounts. And sales data is also often very spotty, and particularly in markets outside the United States, and especially for the food service category. And then the final challenge there too is that capacity is often shared with other product categories. So for example, a lot of companies that are contract manufacturers for animal protein processing will also devote some percentage of their line time or production lines to plant-based meat production. And it's a lot harder to sort of tease out exactly how much is out there. So it's a range. We can come at it as sort of a range, somewhere in the neighborhood of 2, 3, 4, 5 million metric tons, maybe if every foreseeable facility that could do this decided today to produce plant-based meat. But ultimately, like, what's clear is that we need a very significant, probably 5 to 10x increase in that amount of where we are today to get to this particular scenario in 2030.
Yeah, many different factors to consider. Thank you. Ryan, I think this is a question you'd be able to answer for us. What about an analysis for cultured meat products?
Great question. Thanks, Renee. So here we focused on plant-based meat products as a first step, but for cultivated meat, that's definitely a direction we'd like to take this in. The supply chains for plant-based meat, for fermentation-derived products, and for cultivated meat are obviously distinct, but they're also very interrelated. So this is a great next step for us to take the model in, is to model out the production volume requirements for cultivated meat in coming decades. I will say that we are kicking off an analysis that examines the side streams of all 3 alternative protein pillars, and then looks at ways that they can feed into each other to reduce costs systematically across the all protein ecosystem as a whole. Additionally, we're kicking off an analysis that's looking at cultivated meat processing capacity. So we've got more to come, and if you haven't signed up for GFI's newsletters, go ahead and do that, and that'll keep you in the loop about when these reports are coming out.
Well, thanks, Ryan. Lots of good information to look forward to in the coming months and year. So Preet, this is probably a question that you can help with. So given the current lack of framework and structure to introduce new materials, what are some early steps we can take to begin the process of scaling other streams of material up?
Yeah, absolutely. So I think being able to look at new raw materials and process them, and maybe even doing new different processes, including maybe some improvements on extrusion or other texturization methods. In general, I would say the best way to be able to infiltrate these new types of products and processing techniques. It's being able to look at kind of what already exists and retrofitting or repurposing what is already there. So for instance, farmers will have these huge combines that are specifically for soy or corn, and maybe there's just like a part of it that can get swapped out, but they're specifically made for these big commodities. And so it's really hard, you know, if it's a different crop and a farmer's not used to whatever commodity it is, for them to get a combine that can harvest it properly. So being able to figure out, okay, what can we already use that's out there for these really big commodities? What can we use that's already out there? And then how can we actually maybe repurpose it or retrofit it in a way that would be useful? And actually the manufacturing capacity analysis that we alluded to earlier, that we'll be doing for plant-based and fermentation first, and then later for cultivated meat. But for the plant-based manufacturing capacity analysis, we will definitely be looking at specifically that. How can we take what's already existing infrastructure and equipment, and how can we use it to you know, maybe get some more diverse crop sources out there for these alternative proteins.
Yeah, and I'll just jump in quickly too to add, there are, in addition to all the things that Pri was alluding to, like all the farming considerations and farming infrastructure, and you know, there's grain storage and handling and transportation considerations. There's also a lot of like financial considerations here too. We literally need to create markets for new types of commodities and crops, and so that is something that's worth working on. But it's going to take time to do that, right? You know, either through direct contract growing or through, you know, creating local regional markets and you know, your friendly neighborhood grain elevator. So all of that takes work and requires a lot of organization and alignment on the part of, you know, commodities traders and companies that operate in those sectors. There's also a pretty significant role here too for the policy influencers or the policy realm, in that a lot of global agriculture is significantly influenced or controlled in a lot of cases by governmental policies. And so in particular, making sure that there is a really friendly environment for things like specialty crops and not just like high volume commodity crops is pretty important. I think one pretty salient example of this is in the United States, it's often difficult to get crop insurance for more specialty crops that are, you know, maybe more unique. Maybe they're non-GMO, maybe they're organic, or maybe they're just a new type of pea that isn't commonly cultivated, but it's a new cultivar that represents something that could be really promising for plant-based meat and other food and beverage applications. Without crop insurance, that makes that crop a lot less enticing for growers to cultivate. So it's important that we think holistically about the agricultural supply chain. We think about new ingredients, and yeah, to Pri's point, like we really can't just turn all that on quickly, and so that's why like relying on side streams from oil seeds for potential protein sources is sort of the short to medium term solution. But the long term solution is very much a industry, technology, policy, and investment story.
Yeah, obviously something that has to be attacked from all different angles to be successful. Great. So Zach, this next question is probably a good one for you. What are the challenges and opportunities you see on the co-manufacturing model?
Thank you for that question. Whoever asked this, so many challenges. We hear this constantly from different companies that we work with, that there's a lack of expertise or available capacity. Right now, a lot of it's due to just a very high demand for their services, whether they're have a line or facility dedicated to plant-based meat production. There's a lot of demand for that, or they're an animal meat processor. There are plenty of contract manufacturers and private labelers who are just facing a lot of growth in demand for their products and services these days. So, and that creates sort of a challenge when you're competing or bidding against other companies for that, and of course raises cost. The other thing is just fundamentally, like low moisture extrusion is relatively more well understood. There's still a lot of challenges, of course, to formulating a good product, but high moisture extrusion in particular is very nascent compared to other food technologies. It tends to be a very specialized skill, and so a lot of these contract manufacturers, even if they're interested in expanding their business lines into service plant-based meat, don't necessarily have the in-house capability and expertise. It can be hard to find experts. We do have a list at GFI of experts we're aware of for consultants that can help with that. So if you are or know a contract manufacturer who's interested in entering this market, we would love to talk to them and share some resources to help them do that. And then there are other categories of challenge that are probably pretty familiar to most of us today, just given our experience in the food industry and the pandemic related challenges we've seen. But being able to have a labor force and get access to the talent and workforce you need. A lot of facilities are too small and need expansion to add this capability. You need investment. Somebody's gonna have to pay for it. Contract manufacturers are generally not gonna pay up front for equipment that they're not sure if they have customers for yet. So you've got to find the right customer who can help pay for that equipment and find investment or financing for that. And there's really just been a lack of focused concentration within the investors that were aware of active in the space on, expanding the plant-based contract manufacturing capacity. I think that's going to start to change, probably because it has to, because it's a big challenge for a lot of startups right now. But it is definitely a key challenge, and it's like everything else. There's a number of different stakeholders that have to be aligned there. But we're more than happy to help, and I'll share a link in the chat to our database of contract manufacturers and pilot plant facilities, and we'll would welcome any additional contributions or additions to that we're making.
Excellent. Thank you for your insights on that. Very helpful. Pri, I think this is a good question for you about coconut oil. What characteristics or functional properties does coconut oil have that make it desirable for plant-based meat? Isn't the use of coconut oil in foods contraindicated by nutritional research that it may lead to increased rates of fat-resulting diseases? What are your thoughts?
Yeah, this is a wonderful question. So essentially, from a functional point of view, coconut oil is one of the few plant lipids that's actually semi-solid at room temperature. And usually, if you're looking at like canola oil or vegetable oil that you're cooking with, it's liquid at room temperature, whereas coconut oil will sometimes be solid, sometimes be liquid, depending. I'm in Los Angeles, so sometimes it's liquid, but a lot of the time it's solid. And when incorporated into like a burger patty or something like that, it replicates the solid animal fat that you would really see in these products, in the conventional products. And when you kind of zoom into the microscopic level, if you want to, essentially lipids are just these really long chains of fat soluble atoms that interact with each other. And when you're looking at plant lipids, they tend to be unsaturated, and these are the more healthy lipids, so unsaturated lipids. But that means that they have double bonds in them, so they just kink. So instead of the long chains of molecules kind of lining up like this into something more structured like a solid, the plant lipids are kind of kinked, so they can't really fall on top of each other in a way that would make it solid. So yes, unsaturated lipids are healthier, but unfortunately from a functional perspective, they end up not working very well. But we actually just, Ryan talked about it a little bit. We just had a white space RFP, a research program that we're really, really excited about. And we're gonna have some awardees that are working specifically on this problem. How can we have nutritional unsaturated lipids come in a solid form? And just as a follow-up, someone did ask how scalable our alt-fat approach is, and that's a really great question. Coconut oil is it's more scalable than doing more material science on the unsaturated lipids that exist otherwise, which is part of the reason why it's just used instead of people kind of exploring what can be done outside of that. But hopefully our grant program will be part of us exploring outside of that and being able to kind of get the nutritional aspects as well as that really great fat solid functional aspect.
Excellent. It makes me wish I had had you as my organic chemistry professor, Pri. Such a great explanation. Thank you. I see we are at time. Zach, Ryan, Pri, is there anything you'd like to leave us with today before we close out the webinar?
Just a hearty thank you to everyone who attended, and a reminder that this is a starting point, not an ending point. We'd love to get your feedback, and particularly any data. The most valuable data is data that contradicts what we've said today. So please send that in. We promise you will not be hurting our feelings. Thank you so much for your attendance today, and of course your contributions to the broader plant-based meat and alternative protein ecosystem. It's been a delight interacting with you all in the chat and in the Q&A. Such thoughtful and thought-provoking questions. So thank you all.